Welcome, everybody. My name is Ralf Peters. I will be acting as the pro-rector today and guide this ceremony. So hereby I open this academic ceremony in which Renato Rogosic will defend the academic thesis, Biosensors, Customization and Prototyping, how to make point-of-care diagnostics more relevant. May I invite you to present the summary of your study and the conclusions of your thesis.
Thank you very much. Dear Prorector, dear members of the Corona, dear friends and family, welcome to my PhD defense titled Biosensors, Customization and Prototyping, how to make point-of-care diagnostics more relevant. From this long title, I would like to highlight two parts, point-of-care and customization. We will see, in fact, that throughout my presentation, these two concepts will link the interdisciplinary chapters of my thesis. In this presentation, I will break down the work that I did in the last 5 years, and to do so, I will answer three main questions. The first one is, what did I do? The short answer being, I used rapid prototyping, mainly 3D printing. Following, I will answer the question, how did I conduct my research? And to do so, I will show the publications and the main results that stemmed from my research. Lastly, I will answer the question, why did I conduct my research? And I will link to the valorization efforts that stemmed from my work. I would like to start with a quote. To join the Industrial Revolution, you needed to open a factory. In the Internet Revolution, you need to open a laptop. The Internet Revolution changed the way we live and the way we interact with each other, but it also changed the way we produce the goods we use every day. In fact, the Internet Revolution paved the way for the creation of a new type of industry that we call Industry 4.0. The main characteristics of this new type of industry is the integration of IoT sensors in our production lines. These sensors record real-time data that is then used to compute prediction models for improved maintenance, self-optimization of processes, but also for strategic planning. Factories are also changing structurally. In fact, they are integrating new ways of producing goods. One example is 3D printing, which gives the flexibility to produce on demand. Produce on demand also for increased mass customization, which is a concept that started a couple of decades ago from the automotive and the medical industry, but it's nowadays expanding to new types of industries. We will see how my work focuses mainly on the last 2 points described. In fact, I will be focusing on customization and on the usage of 3D printing. If we look at the market of 3D printers, we can define two very different categories of machines. If you look at the upper right side of the screen, we can see 5 pistons printed by Porsche for the 911 GT2 model. These pistons allow for a 10% weight reduction in comparison to traditionally produced components, which ultimately results in a gain of 30 horsepower. The machine used to produce the components, it's a high-end metal 3D printer that costs at around 200,000 euros. On the lower left side of the screen, we see a 3D printer that costs at around 200 euros, and it's used every day from around the world from a multitude of DIY enthusiasts. So it is clear that between these two classes of machines, there is a very big performance gap. The work that I conducted focused on finding applications in which this performance gap could be bridged. So using non-industrial 3D printers for applications such as research, laboratory instrumentation, and later education. Finally, summarizing, the research question that I try to answer can be defined how to design and fabricate customizable, cost-efficient devices for research, for laboratory applications, and for educational tools. The first publication that I will talk about consisted in the benchmarking of a desktop 3D printer, the Form 2 from Forblas. This printer relies on a SLA technology, so laser technology. It's very user-friendly, sturdy design. It has a lot of flexibility thanks to the variety of materials that can be used with this printer. In this study, our goal was to benchmark the printer and highlight its potential and limitations. And to do so, we designed components that allowed us to evaluate the accuracy of the printer with regard with three main parameters: the printing of open channels, the printing of closed channels, and the printing of superficial features. We selected three materials to test: clear resin, tough resin, and high temperature resin. So if we look at the results that we obtained, in this graph we can see the results for the open channels and the superficial features, and we can see that there is not a great deal of difference between the three resins selected. Maybe the tough resin slightly underperformed in comparison to the other two, but overall we can see that we achieved a good accuracy with dimensions at around 250 and 500 micrometers. If we look at the results for the printing of closed channels, we can see that the clear resin slightly underperformed with respect with the tough resin and the high temperature resin, but nonetheless we were able to achieve channel sizes of about 0.5 millimeter, so 500 micrometers. And summarizing, we showed that this printer can be used as a cost-efficient alternative to most expensive and complicated fabrication methods for all the types of applications inside and outside the lab where we need small to medium volume sampling of fluids. So from the results and from the knowledge developed from that first publication, we moved into the second chapter of my thesis, which talks about the rapid prototyping of a biomimetic sensor for the detection of a new psychoactive substance. In this schematic, we can see the three main components of a sensor. We have the sampling, which in this case it's a 3D printed flow cell and an O-ring. We can see the readout. In this case, it's a copper plate with a power resistor and a set of thermocouples. And finally, we have the receptor layer, which is an aluminum plate functionalized with molecularly imprinted polymers. Molecularly imprinted polymers and the heat transfer method are two techniques that share both cost efficiency and flexibility, and for this reason they are often used together in biosensing applications. Usually, a polymeric film is used as an adhesive layer to make the molecularly imprinted polymer particles adhere to the receptor layer. And the focus of my work in this chapter was exactly to evaluate the influence of this polymer layer on the performance of the sensor. In order to do so, we selected three polymers that for simplicity here we call polymer 1, 2, and 3, and we analyzed its performance. In detail, one of the main characteristics that we chose to analyze was the surface coverage of the receptor layer, because of course it influences directly the amount of area that is available for the target to be bound to the receptor layer. So we finally show that the type of polymer, so the different polymer film used in this application, does indeed have an influence on the sensor performance. And in particular, we show that polymer 3 has an increase in the response, especially at higher concentrations. So we can say that this study can open up for the possibilities of more in-depth future studies when heat transfer method and molecular imprinted polymers are used together. We continue on the path of rapid prototyping used for laboratory applications. And in this publication, I will introduce you to a 3D printed syringe pump controlled through a smartphone application. Syringe pumps are used in a multitude of laboratories around the world because they allow researchers to control small flow rates with accuracy. We chose to design our own syringe pump, and when doing that, we selected three main characteristics. These were the cost efficiency, the user friendliness, and the flexibility of the design. So we 3D printed all the hardware components, and we selected off-the-shelf electronics for the electronic board of the pump. As I said, to maximize the user friendliness, we developed a sturdy design with a battery to increase the portability, and of course a smartphone application with an intuitive control to maximize its user friendliness. We characterized the performance of the pump, and we saw that it was in line with the DIY alternatives in literature and also some of the commercial alternatives available. So not only we showed that the performance of the pump was at least satisfying, but we also addressed some of the main shortcomings of similar alternatives on the market. For instance, commercial pumps are quite expensive, and the DIY alternatives in literature can be complex to fabricate or to utilize. By maximizing the user friendliness of our device, we ultimately allow a larger pool of people to utilize laboratory instrumentation. In the last two chapters, I talked about usage of rapid prototyping in laboratory and research, and now we move on to a new field, which is educational tools. In this application, we show the fabrication of a modular science kit in which the concept is to capture the attention of the user by visualizing scientific phenomena. I think that the best way to understand the concept is to see a short video. So here we have the set of transparent blocks. We have as well a set of pumps that will allow us to push the fluid through the system. And as I said, by combining the blocks together, we can build different fluidic channels. In the first experiment that I'm showing you, that we call veggie alchemy, we investigate the presence of a pH-sensitive molecule in cabbage juice. So we are inserting in the system right now cabbage juice, lemon juice and baking soda. And we see in the observational chambers in the front how there is a change of color that is due to the change of the pH of the environment. In our second experiment that we called fruit caviar, we are staying in the chemistry and we are seeing the espherification process of an alginate solution in calcium chloride. Lastly, we see the space juice experiment, and here we move into physics. We have two small submarines that we fill with oil. We put them in the reservoirs that then we fill with our syringe pumps. We have oil and water, and with this experiment we can introduce concepts such as buoyancy and density. So summarizing this work, we successfully managed to fabricate a modular science kit that we would like teachers to use in primary and secondary school to address the STEM gap from an early age. However, when this work was developed and when the work was published, there were corona measures in place, and we were not able to go and field test the kit. But luckily last year we did an external collaboration with the Open University of the Netherlands, and we managed to go to some schools and do a study. From that study there was a publication that showed both qualitative and quantitative data. And one of the main results that I believe are crucial is that the group of students that use the Fluigo kit showed an increase of the perception of science after using the kit. So in the last part of my presentation, I would like to talk about the valorization efforts that stem from my research. This part is a natural continuation of the last chapter that I just described, but it's also the result of all the experience and the path that I had during my PhD. In September 2019, together with a colleague of mine, we joined an internal competition to which was themed Science for Society, and we brought our idea of creating a science kit for children. The idea was very well received, and because of the enthusiasm of the people, we won the prize, and together with the help of the university, we brought the project forward. We improved our kit, we filed a patent, and we managed also to open a startup, so a company, a commercial entity. And finally, in November 21, we established a commercial agreement with 26 schools in Limburg. And currently, we are collecting feedback for optimizing the kit and hopefully launching it on the market. So I started with a quote. I would like to finish as well with a quote. This is from Rainer Weiss, Nobel laureate in physics. He said that it's fundamental to work on things that are fun. My life was never dedicated to win a prize. It was dedicated to work on things I enjoyed. Thank you very much, and I give back the floor to the prorector.
Thank you very much for your clear presentation. Before we move to the discussion, I would like to introduce the supervisory team, because in Maastricht it's customary that they will not be asking questions. So we will be having Professor Thomas Klei, Dr. Bart van Grinsven and Dr. Casper Eersels, will be supporting the candidate, and they've already put a lot of time into this project, obviously. So now let's move to the opposition. The opposition will be opened by Professor Wienans. Professor Wienans holds a chair in machine reasoning at this university. He was chair of the assessment committee, and he's today acting also as secretary of the degree committee. Please, Professor Wienans.
Thank you, Pro-Rector, for introducing me. And dear candidate, dear Renato, I've read your thesis with much pleasure. I learned a thing or two about point-of-care diagnostics and rapid manufacturing. My compliments, which I would like to extend to your supervisors as well. Of course, I have some questions. Here, I would like to start whether you can help me to solve a mystery. As you know, I'm part of the Department of Advanced Computing Sciences, and one of our hobbies is to have a closer look at software. And then I would like to take you to the appendix of chapter 5, pages 134 till 145, where you have listed some Java code, my favorite programming languages, very good, consisting out of two modules, processing code and control page. Now, the code on pages 134 till 139 appears to be similar with the one listed on pages 144 till 145. And my question is, what is the difference between these two versions of processing code and control page? Because I couldn't see it, but maybe you could help me here.
Highly esteemed opponent, thank you very much for your comment. This indeed, the appendix that you see here is the processing code that I designed myself. There might be, just a little introduction, there might be a bit misconception because the pump, it is controlled through a smartphone application. Yeah. The code for that smartphone application is not, of course, included here. This is a side code that I designed to give the possibility. So this is open source, of course, available to everyone. This is, I used processing language, which it's very intuitive, very graphic, and everyone has the possibility to adapt the software and control the pumps. So it works exactly as the smartphone. Going back at your question, if I might repeat, you were wondering what is the difference between the code in page 134?
Yeah. So I'm seeing two versions of processing code, that class, and two versions of control page. So I was wondering, is there a difference, or is it a copy, or?
So I see in the first part, so processing code, we have control page, there we go, 136. I think you just highlighted an error in the printing of the thesis.
Oh my goodness, you have printed too much.
I think that's the case,
yeah. All these course.
I think it's printed twice,
yeah,
yes.
Okay.
Yes.
Then there's something else, and I would also like your views on that, because I was wondering a little bit, because in the processing code, you define a couple of variables, and they are about speed and acceleration and choice direction, etc. And there you're using as type floating points. And I'm wondering, why didn't you use their double as a type here? Because why floating points? Because, yeah, okay.
So I have to say, I'm not very, let's say programming is something I like, but I kind of learned step by step. I understand the question.
Yeah.
I agree perfectly. I don't believe there is a reason, because the string that I send from the software to the pump is just a string of 4 integers, if I remember correctly, and each of those integers controls one parameter of the pump. So we have the speed, we have the acceleration. Actually, I think it's constant. One of the two parameters just says the direction, so it could be a +1 or a -1. No, sorry, a 0 or a 1. And the last parameter.
So my question is, because if you use floating point, that's 16 bits, and if you have double, you have 32 bits, so there is a higher precision.
Yes.
So would it matter in the end?
I don't think it would matter for the function of the pump.
Yeah.
It would, as you said, probably occupy a bit more memory, which is not.
No.
It's it wouldn't make a difference for the function of the pump, because, as I said, the driver that it's on the board of the pump just takes into integers.
Simply integers. So there's no no accuracy problem. Okay,
no,
that's good to hear.
Exactly,
okay, I'm happy to hear this. Okay. Then I would like to move to chapter 4. And there you present your pump, which you claim to be affordable and customizable.
Yes.
And moreover, you state on page 77 that the pump is extremely user-friendly.
Yes.
And take this adverb into account, extremely. And this suggests that you have created the ultimate user experience in controlling such a pump. So my congratulations. But then I was wondering what kind of evidence you have to make this claim that your pump is so extremely user-friendly. Could you elaborate a little bit here and convince me?
Yes, I will try to convince you with the post phase to that chapter. In fact, I was lucky enough to have the chance of convincing MSP, Maastricht Science Program, that is a bachelor course that we have at Maastricht University, to use this pump as part of the material in one of their courses. And because, as you said, it was quite difficult. It is quite difficult when you talk about evaluating user friendliness of a device to actually collect data. I kindly asked all the students and also the tutors. I think it's specified around 20, 30.
20, 30.
I will tell you immediately. 24 responses I got.
Okay, and they all gave the perfect score.
Not perfect, but we can see that, for example, at page 100.
But then it is not extremely user-friendly if not everybody's happy.
That's debatable, but I understand your point indeed.
Because, for instance, no, but I'm not joking here. What about users with a visual impairment? Would they have issues with your pump, or is it still for them?
They would, but it is indeed a very good observation. I think that an added value to such structure of devices is that they are really easily modifiable. Yeah. So both the software and the hardware, it's open source, 3D printing.
Does the software adapt itself to the user needs?
Not yet.
Okay.
Maybe in the future, but that will be really, interesting.
So my point here, you can only state that if it is extremely user-friendly, if there's no way to improve it anymore, and also that you have a large set of users also claiming that it's very user-friendly. But okay.
Yes, I understand.
Yeah. So you understand that don't think it is extremely user-friendly. And now I'm looking to the proactor if I still have
1 more minute.
1 more minute, yeah. I think that is the most important question here. So in chapter 5, you also introduce your educational toolkit aimed at children from 8 to 14 years in order to encourage and stimulate learning in science, technology, engineering, and mathematics, so-called STEM. Now, when reading that chapter, I understand that you also encourage students moving into the chemical field. But what about the M of mathematics here? Does it also encourage that aspect? So if you could briefly discuss it.
Very briefly, the added point of, let's see, the strong point of this kit that we believe is the modularity. Yeah. So we have, you can imagine it as Lego, but with channels inside. So we have some basic blocks, and then we leave the possibility to create new types of experiments. So in this particular study, we only have these 3, but for example, as I said in the valorization part, we further developed the kit, and we already have around 7 or 8 experiments in various fields, and we also have one in mathematics, between mathematics, geometry. We work with fluids, with shapes, volumes of different blocks, calculation of volumes. So the idea is that with the modularity of the block, you can move into different learning fields.
Okay, thank you for this answer.
Thank you.
Thank you, Professor Wienans. Then the opposition will be continued by Professor Doll. Professor Doll holds a chair in biomaterial engineering at the Hannover Medical School, and he's also affiliated with the Fraunhofer Institute for Toxicology and Experimental Medicine, and he was a member of the assessment committee. Please, Professor Doll.
Thank you, magnificent. Dear Renato, I find it very nice to read your thesis. And it was exceptional because your thesis is spanning such a large frame of an entire field which normally goes into a book or habilitation. But at some points I was missing some details. And I think this is now the right place to ask for details. I will focus on the paper written by you and your paranymph Joseph, and which is on the MIP powders. The first question is the MIP powders. Who prepared them? Which materials have they been? How did you them deposit? And finally, how did you wash off all the imprinted polymer?
Highly esteemed opponent, thank you for your question, your comments. That paper indeed, that publication, refers to the molecular imprinted polymers, and those molecular imprinted polymers have been synthesized for a publication, so we refer to them as literature. So I did not synthesize them myself, I just used them, prepared. I did the deposition process myself. There is a short description in the thesis about the monomer, the crosslinker, and all the chemicals, let's say, used to synthesize the molecular imprinted polymer, but those were taken as already developed for 2-MXP, so the new psychoactive substance. What I did with the deposition, I followed also followed literature. So HTM and molecular imprinted polymers, as I said, it's a well-assessed technique. The deposition process, it's a bit of a criticality, and there are solutions in literature that try to avoid the manual deposition of the molecular imprinted polymers, for example, grafting of the molecular imprinted polymers. However, for this paper, I maintained all the procedures from previous studies in literature, and my focus was generally on an engineering approach to see if this polymer, only the composition of the polymer layer had an effect.
Just did you squeeze the dust over the substrate, or did you blow a dust like that? So I got no clue about how you did it.
I understand. We raised the temperature of the polymer film above the TG of the polymer. Then we deposited just by dropping the polymer powder that was sieved previously, so the particle size was homogeneous. We deposited it, and then we stamped it manually with a PDMS stamp.
Okay. I'll take this as an answer. How did you wash off?
We wash with the water.
Pardon?
We just wash with the water. So we used after the polymer had cooled down. We left 5 minutes to cool the polymer layer. We washed it with water to remove unbound particles.
Did you check if the mattress is already gone?
No, we did not analyze if unbound particles were still there. We assumed that washing with water would remove unbound particles.
Thank you. Second question is the results you achieved. The figures are 3.4 to 3.6. You say basically you have presenting then some results, and finally you come up compared with reference number 17. We have some sort of results, and so I did not read that normally you would describe what is given in reference number 17. This is a paper by your supervisor. Yeah, so a little bit more than we have better results than number 17. So this is now the floor to explain what is better.
Yes, I understand the question. I can say that First of all, I would say that the structure of the paper itself, also how the results are presented, it's more focused on the evaluating the influence of the polymer layer. So if there is, because that's something that in literature has not been studied. So PVC, which is polymer 2, has been used as the main adhesive layer, and I didn't find any other study that tried to see if there was actually a difference if that polymer layer was changed. So we were more focused on that part rather than comparing the performance of the sensor to previous studies. It has to be said, I believe also that with molecular imprinted polymers, it's a bit tricky to compare intra-batch receptors, because there is a lot of variability. So also maybe because of that, we did not choose to make a direct comparison with other studies. And I believe that would be a bit difficult for me to give an answer whether this sensor works better than other solutions, like previous literature.
Last question. A PhD thesis is normally describing the advance of science and technology. Please give a critical evaluation of what you have done here in this paper towards state of the science of an art.
Yes. What has been done in this paper, I believe, is it has been highlighted how the composition of the polymer layer used to immobilize the particles does influence the performance of the sensor. And we show that in comparison to literature, which has been always using polymer 2, we do achieve an increase in performance. So we see that both polymer 1 and polymer 2 have a better dynamic response with comparison to polymer 2. So we open up for the possibilities of an in-depth study. So we open up for the possibility of future studies that go more in depth into how this layer influences the performance of the sensor and how to optimize it.
So did I understand right, the reference number 17 is already using polymer 2?
Yes.
Thank you.
You are satisfied with the answers. Thank you. And the opposition will be continued by Professor Toelen. Professor Toelen holds a chair in engineering materials and applications. And he's also the Dean of the Faculty of Engineering at Maastricht University in Belgium, and he was a member of the assessment committee. Professor Toelen.
Okay, thank you. Dear candidate, thank you for the nice presentation, also the thesis. It was a nice example how engineering research makes a difference in designing applications for diagnostics, but also making young engineers, young children enthusiastic for science. So that's very nice. Thank you for that. I also have some questions regarding your work. I'll begin with the beginning, and that's chapter 2. There you investigated different resins to make microfluidic chips. I was wondering, did you also investigate the chemical adsorbance of these materials on, for example, because you state that the MIPS itself, you use cells, proteins, small molecules. How do you interact with these microfluidics?
Highly esteemed opponent, thank you for your comment and question. Unfortunately, we did not investigate, as you said, chemical absorbance on the surface of the 3D printed flow cell. That might be indeed a very good follow-up. Also, I believe because this type of flow cells very often are used for cell culture and biological applications, probably also cytotoxicity could be another follow-up study that can follow. The focus of this work was to take what was readily available, so 3D printer that was high-end 3D printer for being a desktop 3D printer, but still a non-industrial and quite available 3D printer, select some of the materials and select them based on the potential application that they could have, so transparency, high temperature, and mechanical properties, and evaluate how to optimize the printing of devices using those materials. That was the main focus of the work.
Maybe to follow up, I saw the manual of your science kit.
Yes.
I didn't find anything on washing the blocks after
Yeah.
Because that also triggered my
Yes.
question.
Yeah, that's a very good point. We try to tackle that problem only by using water-based solutions. So we only use water-based solutions. So with soap, we try to clean everything. That's probably something that we have to take into consideration for sure. But we already did. We are trying to find solutions to that.
Okay, thank you. Then on chapter 3, there was already a discussion on the MIPS imprinted on the sensors. You use an adhesive film for this. I was wondering, because I think you always use the same settings for the spin coating of the different polymers. Did the different polymer layers obtain the same thickness in film? And how does this thickness or difference in the thickness influences either your results on the thermal characteristics of the film, but also on the actual application of the sensing? Can you relate on that?
Okay, so I will start by saying that we use those parameters from literature, from polymer 2, so PVC. It is shown in literature that use these parameters at this concentration in the solvent. It allows to obtain thicknesses of around 100 nanometers, and that's the standard, that's the literature. So we did not want to change too many parameters at once because we already are changing the composition of the layer. So we use those parameters for polymer 2, and then we did some qualitative studies on polymer 1 and 2 with the concentration in solution with their solvents, and we made a guess that we would obtain similar thicknesses because of the similarity in viscosity of the solutions. Another consideration that we did, and also another reason that maybe we kind of forgave ourselves not to do more in-depth analysis, is that these layers are quite thin, and the heat transfer should not be altered too much because of the thickness of the layer. So if we were talking about higher thicknesses, that might be a problem, or might be at least necessary to investigate. We assumed that with these thin layers, with such setup, it would not influence too much the performance of our sensor. And this, I believe, it's also a bit confirmed by the data that we show at page 67. And here we are calculating some thermal properties of the layers without the molecular imprinted polymers, so only the polymers covered there. And we see that the thermal response is comparable between the polymers.
And do you think the roughness of these polymers also plays a role?
No, we did not investigate that. We also kind of refer to literature. There is a study that studies PVC, polystyrene, and PVB. So it's a bit different indeed from our polymers, but they still show, they did surface analysis, and they show that the layers are homogeneous.
Okay. And then I have a question as last on chapter 4. It was already mentioned to prove the user-friendly. That's important. But also the technical performance. You described that the pump worked smoothly and consistently. You showed indeed a table on the variation, but would you imagine a technique to really make it feasible or tangible that smoothly and consistently the apparatus?
I think that's a very good comment, and it's something that I experienced while I was trying to characterize the performance of the pump. So I went to see the data sheets of all the other commercial alternatives, and they were saying what is the minimum flow rate, what is the maximum force. But when we talk about, we always say in this kind of devices, one of the most important parameters is how consistent and constant it's your flow rate. Because of course, if you have a stepper motor, you do one step, then you wait, you do another step, you have very small flow rates, but your flow rate goes like this, and that's something you don't want to. But I never found any type of parameters to describe this. I call it smoothness operation. it would be indeed nice to have such a thing. Maybe I missed it. Maybe it is out there, but probably I don't know how interested there is, because many of these devices are commercial. So maybe they want to keep it like that, just saying what is the minimum flow rate, which of course it's very low, but doesn't mean that it needs to be a smooth flow rate. We included as a supporting material a video of the operation, and there it is possible to see on the scale how fast, let's say, the volume is administered. But I agree that it would be beneficial to have an indication of this smoothness of operation.
And then related on that, you showed in your table that the error margin is quite constant over a wide variety of flow rates you investigated. Can you pinpoint a technical feature which resulted in this constant error?
Because the error is constant, so it does not depend on the amount, so it's on the amount that is administered, so it's not dependent on the time that the pump is on. So I assume it's an error simply maybe between disparity of the volume that one wants to deliver and the discrete steps of the motor. So there will be an error that is intrinsic to the amounts that you want to deliver. So no matter if you deliver high or small volumes, it's a constant error that it's there. It's not dependent on the volume, indeed, on the time of the pump.
So you say it's the motor that caused
I
this
would say that it's the discrete nature of the steps of the motor that turns.
Okay, then thank you.
Thank you.
Thank you, Professor Toelen. Then the opposition will be continued by Dr. Harings. Dr. Harings has an area of expertise in macromolecular physics and technology, and he's affiliated with the Maastricht Institute for Bio-Based Materials at this university. He was also a member of the assessment committee. Dr. Harings.
Thank you, Pro-Rector. Dear candidate, dear Renato, congratulations with the completion of your thesis and a very clear presentation. Like the others, I also have some questions, but I would like to ask one of the paronyms to read the proposition number 3.
If you can imagine it, you can design it. If you can slice it, you can print it.
Well, I'd like to elaborate a bit on that statement. So in the past 4 to 5 years, you have explored multiple 3D printing techniques, I think more than our group did. And I think you rightfully consider yourself as the expert. I also consider you as the expert. But the proposition consists only of 2 sentences. And is it really that simple? The reason I'm asking this is that our team, some of your very good friends, have been working for 6 years on realizing the performance of the imagined 3D printed object. So if I think about your Lego kit, which is a very illustrative kit, you don't want it to leak, especially if you're pumping chemicals at primary school, right?
Of course.
So in terms of performance, may I ask you to include a 3rd sentence to the statement in terms of functionality, and what would be its core message?
Hi, esteemed opponent. Thank you for your question and comments. Well, thank you very much for considering me an expert in the field. I think that the work that I did indeed gave me a lot of insight into 3D printing and prototyping techniques, but I also think that my approach was, rather than trying to master the ways of 3D printing and trying to focus on maximizing the performance of the material, it was more into using what is there and adapting it to the needs. So design a smart device around what the performances currently are, and not trying to push it too much. So most of my experience is with PLA. I did print with other materials, okay, resins, okay, I used resin printing as well. I think that in the last years, materials developed a lot. There is a wide range of materials nowadays and with a wide range of performances. And of course, the proposition is very optimistic. That there are some limitations to the performances. But for example, one thing that I really believe could be the future, at least for small batch production, it's, for example, the fabrication of molds with 3D printing, which cuts drastically the costs, and then you can again produce with the fabricate with the materials that have better performances, and then you overcome those that limitation of 3D printing. That's one point. Maybe another point is that, referring back to the proposition, you can imagine it, you can design it and print it, because 3D printing allows us to overcome some of the limitations of traditional fabrication techniques, for example, injection molding, so we can have more complex shapes. And an example is, for example, the piston that I showed that was printed with a metal printer. So because you don't have the constraints of a CNC milling machine or injection molding in case of plastics, then you can create more complex and more optimized shapes. I hope I answered it.
Yes, thank you very much. One last thing there is, because do you think then does this statement applies to you or also to secondary school kids? Because I've been at the open days of the secondary schools in the neighborhood for our daughter. They all have 3D printers. So could they produce these kits themselves?
That's our goal. We believe that eventually that's going to be the case. What we saw, for example, working with primary school kids, we have this manual in our kit. Then we have six or seven experiments that are pre-made, and you have the circuit that is built. But they just start building random circuits. They just use their imagination, and that's something also that we believe it's an added value of the approach. And the next step, of course, would be to start designing new things and printing new things. It's maybe, it will maybe a bit older children, but that would be our goal for sure.
Yeah. Okay, thanks. So let's go to one of your chapters. And as you know, we're both engineers, though I'm engineering basically on molecular scale. So I'm very intrigued by the concepts you push forward. And indeed, in chapter 3, I also have some questions on the adhesive that you use. And I understand from the document that PVC is conventionally used. Huh?
Yes.
And then you mentioned that you basically immobilize the MIPS by heating above the glass transition temperature. Was that equal for all three polymers?
No, we tend to go, we used to do 10 degrees above the TG for 2 minutes. Mm-hmm. So for PVC, we select around 100 degrees, 95, 100 degrees. For the first copolymer, I think the TG is slightly lower, 10 degrees lower, and for PS comparable. So we check the TG of the specific material. We raised it by 10 degrees to be sure to be in that range, and then we just heated it up for 2 minutes.
Yeah, okay. The reason I'm asking is that if I look to the chemistry, and I don't ask you to explain the chemistry, I know you have different background, but still, if we talk about the glass transition temperature, and the name of the third polymer is quite exotic. It's a polystyrene block polyethylene ran butylene block polystyrene. So it's a blockopolymer.
Yes.
Right? In fact, it's a rubber because it has 2 glass transition temperatures. Yeah, so the middle block, it says that it's the polyethylene random butylene, has apparently a glass transition temperature of minus 55 degrees centigrade. So if you would heat it above the glass transition temperature of the polystyrene, it becomes extremely low viscous. So you use a sedimentation technique to immobilize your MIPS, but could they completely sink? And what, in terms of figure 3.3, of the surface that you detect is truly accessible?
That's a good comment, and we did not take into consideration that in our study. So you are suggesting that the material, because of its nature, could be degraded or could not offer an adhesive layer, could not serve its purpose.
Oh no, what I actually meant is that it becomes, no, it won't degrade. I think these are very well stabilized polymers. But it becomes, since you have two glass transition temperatures, one fraction of the chain is, at the time you deposit the materials, let's say at 80, 90 degrees, more than 100 degrees above its glass transition. So that means that the overall viscosity is extremely low.
Understood.
And that affects your surface tension. So imagine you would have floating particles, then suddenly you heat above this highest glass transition temperature, don't they completely sink?
Yeah.
So if they sink in the, let's say in the glue, in the adhesive, they are no longer accessible. And that would obviously affect your data.
Yes. It has to be said in this case that these particles are on the size of it's written, I believe, between 10 and 25 micrometers. So they are much bigger than the layer. So I think that should be fine in the sense of sinking. I was, when you were explaining, I was more concerned about maybe the polymer, let's say, getting off of the receptor layer. But with regard to the sinking, that should be fine, because the particles are much bigger than the layer itself.
Okay, thank you. Do you have any wishes for the best adhesive? In terms of thermal behavior, what should it, or
in terms of thermal behavior, we can see from figure 3.5, we see that they are comparable. Also in terms of thermal conductivity, they are all quite similar. I saw that there are some research papers in which they try to increase considerably the thermal conductivity of polymers. I cannot go in details in the chemistry because it's not my field, but I saw that they achieved much higher thermal conductivities, around 20 times the conductivity of these polymers. So maybe trying to use those could be something of interest. Again, as I said before, I don't know how much, because of the thickness of the layer, which is very reduced, I don't know how much this would influence the measurement itself. I'm not sure if it does have if the fact that it does not have thermal conductivity, if it influences the performance. Maybe it's negligible because of the thickness.
Okay, then you have answered my last question as well. Thank you very much.
Thank you.
Thank you, Prorector.
Thank you, Dr. Heinz. The opposition will now be continued by Dr. Pauly. Dr. Pauly's expertise is in physics, material science, and science education, and he's affiliated with the Maastricht Science Program at this university, and he was also a member of the assessment committee. Dr. Pauly.
Thank you, Prorector. Dear candidate, Renato, congratulations on completing your thesis. It was a pleasure for us to read, as you've heard from the other members of the Corona. These are the last 9 minutes of being a PhD candidate, all being well. And I'm pretty sure I met you on the first or second day of being a PhD candidate. So it's been a pleasure to watch the last 3 or 4 years whiz by. And now it's a pleasure to ask you a few questions about those years as well. My first question is about Proposition 7. Maybe one of the parents would like to read that.
Evaluating the efficacy of a new educational method is at least as complicated as creating one.
So my question relates to the postscript of Chapter 5, page 148. You have a table of results from measuring the efficacy of your educational method. And I'm going to put on my cynic's hat and say, actually, all your data is the same. Can you convince me otherwise?
Highly esteemed opponent, thank you for your comment and question. I would not try to convince you too hard, because indeed that's kind of what transpires from these results. The point is that I believe it's really very difficult to evaluate the efficacy of such an approach, especially we're doing only. We have a number of students, I think in total was around 100, 100 primary school students. So I think the number is too small, only one experience, and also a bit, I don't know how relevant this type of questionnaires are. In this case, we are showing the data for just the appreciation of science. So this is not referred to if they learn the concept that we are trying to teach them. It's just how they perceive science. It has to be said that together with this quantitative data that we had to show, because you had to show some quantitative data in a publication, but we also did, actually not me, but the researchers, the authors of this study, did also qualitative data, and they were unbiased, because I was not, that's why I did not participate in the study. They were external people, expert in education, and they saw that the attitude of the students, the children, changed when they were using the Fluigo kit. And also some of the teachers said that allowed them to see some aspects that they would not have been able to see otherwise. For example, imagination, creativity, interest. And I do believe that's also part of the game. That's also something that we would like to address. So we would like to try to bridge this gap, this maybe the fear that the children have about science. So it is difficult to evaluate, I believe. It's quite complex. So I don't want to try to convince you that this data has statistical evidence.
Okay, that's good. In the chapter, or in the paragraph above, you do talk about some of these, let's say, stories that you got from the classroom, that the students were increasing the enthusiasm, that they were more cooperative, that they were more creative, and so on. Now these are, or this is an anecdote. Many anecdotes doesn't make data. One of your promoters has a catchphrase, "Show me the data." So what would you design, or what would you do in the future if we had more time, more energy to spend on this, to gather some meaningful scientific data that would encapsulate those anecdotes and turn them into data?
Yes, indeed. Show me the data. That's why this part of the work, it's in the post phase, so it's not inserted, let's say, in the official part of the thesis. I think it would be necessary to involve in this type of studies people that are expert in pedagogy. So maybe talking with them, they could give you an insight. But to be honest, from the research and from what I saw in the development of this kit and in implementation, there is no one way of evaluating such things. There are so many variables at play, and also time-wise. You should follow all these children for a long time, and how do you evaluate if something is, if a learning method is better than the other? So I believe it is indeed very difficult. Maybe it is also difficult because these type of approaches that are based on hands-on approaches, it is not so easy to adapt them to direct teaching. So in direct teaching, you have chapters, you have how do you say, you have requirements that these children have to achieve. But if you want to apply to all of them this type of on-hands approach, you should develop one experiment for every chapter, and that's a bit complicated. We hope to do it with our modularity. We will try, but if there is a correlation between what they should learn with a directive method and with hands-on approach, then maybe it would be easier. Then you can actually compare in 1 year, so just following the path, exactly the concept that they should have learned, and maybe also the attitude that would allow them to learn them better. So I would focus on that if I could have, if I had the chance.
Okay, do I have time for one more question?
Oh, yes.
Great. Then in chapter 6, page 152, 153, you talk about some of the drawbacks of using 3D printing in laboratories, such as needing to have the capabilities of surviving thermal cycling and things like this. And so on the one hand, 3D printing offers a lot of possibilities for labs to use for things that they need to produce in large quantities, saves on shipping costs and so on, and customizability. But you also mentioned a whole bunch of reasons why it doesn't work. So I just wondered, sort of to wrap up, are there prospects in your mind for rapid prototyping or rapid manufacturing that can overcome those areas? Do you see that 3D printing is going to have a renaissance in the laboratory setting, or is it really not the right technique to use, in your opinion?
I think one of the solutions is to just make it so easy and cheap to produce, to just produce it again when it fails, when it mechanically fails. So just so, or even better, to make such a smart design that only some small parts can be changed. So modularity, and that also allows for customization. So it is both customizable and both repairable very easily. So I think that's one. I think that's where the future of 3D printing will go. So it will not substitute the traditional production methods, but it will just integrate it. So I believe that's the future, from my point of view.
Renato Rogosic, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. And I request that you and your company await the results of our deliberations and our return in this room. I adjourn.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Southside, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. All your time, 'cause I'll go the extra mile. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Get the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. Even though these nights seem long, I know that I am never on my own. Know you won the battle once you grow. Southside, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Years can't fly by now, don't waste all your time. 'Cause I'll go the extra mile.
I reopen the session. Renato Rogosic, the degree committee here present has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Klei is authorized to confer upon you this academic distinction in accordance with the Dutch university system. I invite your supervisor to now take the floor.
Please all rise.
Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
I promise.
By the authority vested in us by law, in conformity with the decision of the committee here present, I hereby confer on you, Renato Rogosic, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee and affixed with the official seal of the university. Dear Renato, it's of course my opportunity to first congratulate you, and that is very nice work. But you also realize, and the committee knows, and perhaps some people in the room know, that you are a little bit unlucky because you are having a dean of the faculty as a supervisor. So in essence, I'm running 80 hours a week the faculty, and you rarely see me. I correct occasionally a thesis, a chapter, and things like that, and bug you about some things. But I was rather absent, and of course the day-to-day work, really to work with you, happened next to me. So. Dr. van Grinsven is the one who is going to do the laudatio to you, but congratulations very much. It was a very nice day to watch.
Thank you.
Dear Renato, what a ride. It took a bit longer than we anticipated, but you did it. After 5 years, you are now Dr. Rogosic. In true ASI fashion, I need to come up with a speech, but in your case, it was a bit harder. Some things can be said out loud. Some things we shall never ever mention. In general, when somebody starts his or her PhD trajectory, we also witness how somebody grows up, both academically, but also in life. In all honesty, I did not see coming what happened to you. I can still remember your application for this PhD position. At that time, there were no PhD students, and we were in the position to hire 3 PhDs. You were number 2. When I first talked to you, you came in like a fully matured engineer, a man of the world. Armed with short hair, background glasses, and a leather binder, you started the conversation. It was as if you were interviewing me instead of the other way around. You asked questions about the project, colleagues which you wanted to have calls with up front, salary, and you even immediately mentioned that you wanted to do a Dutch course. It was after this talk that I even said to Casper that you might be a bit too serious for us. But then, you started your trajectory, and it was entertaining and amazing to witness your journey. You went through your PhD like a scientific Benjamin Button. It did not take long before you got rid of the glasses. Your leather binder I have never witnessed ever again, and after some life choices, you hooked up with your new roommate. Certain chapters of this tumultuous period I shall leave to the imagination, but what I can say is that you even got rid of your short hair, up to the point where you rocked a man bun for a while, and next to that you started a company, and the uptight engineer I once interviewed was nothing more than a fake memory. During this transformation, you managed to do your research and combine it with a fair share of education. You are the last of the first generation of SE PhDs, and you have witnessed the expansion we went through. Sadly for you, you were, next to me, the only engineer, which did not change during the entire expansion, meaning that you were the only person who could help me with my educational load. For me, this is both a happy and a sad ending. I could not be more proud that you pulled through. It took a bit longer, you had to rewrite your thesis, but you made it to the finish line. On the other hand, I'm losing my partner in crime. No more laughing together about burning circuits, the sheer disappointment when grading electronics exams. It wasn't always fun, but at least we tried to do it together. I'm going to miss our talks and our laughter, but I'm very happy with where you are now. You'll find a place for yourself in Utrecht. I wish you success in your endeavors, and you will always be a member of the SE family. Don't be a stranger. Check in every once in a while. Good luck.
Thank you.
Dear Dr. Rogosic, also on behalf of Maastricht University, I congratulate you with the degree you have acquired, and I would like to extend these congratulations to the family and the friends and the supervisors and the people you've interacted with. And on a personal note, also from the graduate school, you were one of the very first members of the representative team when the school was founded in 2020. So thank you for all your contributions there. It was also an enjoyable period. That brings us to the official end of this meeting. So the official part is hereby closed. Maybe a few instructions on how to proceed further. We're going to make some photographs, probably on the stairs over there. And then there's going to be a reception. And I understood that it's not going to be in this building. So we're going to have to follow those who are organizing the reception. Left, right, until we get to the designated location. So keep an eye on us. Thank you very much for attending.